Well, hello, hello. Here we are on our first video. So the purpose of the videos are you going to watch these outside of class, and instead of going home and working on some homework and kind of getting some of it and not getting others. um, all I'm asking you to do is watch this video, participate. There's going to be one or two questions that you will enter answers for. That'll be my ability, so I can give you points for doing your homework. And then in class is when we kind of do one or two problems together. Then I say, all right, I am here for you. And you guys will work in class and get the practice in class work done. So we're kind of flipping it a little bit. Hey, it works for a lot of people. Some people this doesn't, but you're going to have to hold yourself accountable, and I will do my best to help you out with that. Hey, without further ado, let's rock and roll. So today we are going to talk about length of a line segment. That is it. So it's kind of like, well, I can measure something. I can do that. Well, in geometry, we want to make sure we're using the same vocabulary. I'll tell you, that's the difference in so many things of your life, is that you can get minimum wage, but without really any more skills, um, you have this new vocabulary and a new way of looking at something, and all of a sudden you're making more. So think about it that way as, hey, you have a lot of common sense, but why not take it to the next level and open your horizons? And it does give you more tools to do more things. So um, today, the ruler postulate is kind of like how to measure. We are not going to copy segments, so that's too bad. That's a whole idea about using a straight edge and a compass, but we will use the segment addition postulate. And this is what I'm talking about. You're going to laugh when you see this in action, because you're like, that's called common sense, Mr. Sayers. And that means you have plenty of it. Hey, in geometry, a rule that is accepted without proof is called a postulate. So we're going to get a lot of rules and a lot of um, things that we're going to run by. And some are going to be super obvious, and some are going to be like, really? No way. Is that cool? Or is that true? And we're going to have to do some proof and like, oh, okay, yep, yeah, I really do believe it. And we'll call these rules postulates if we don't prove them. We usually don't prove something that are so basic and so obvious that we don't need proof. Another word for this is called an axiom. This book uses the word postulate more than axiom, but in another book they say, hey, the axiom, and you're like, what? You'll be like, no, that's just a rule that has not been proven. All right. Hey, I'd like to start out. In my experience, everybody's coming from different backgrounds, and I'd like to do a few little warm-up problems that hopefully are obvious. So, plotting points. 8. Let's move myself over here. So if I want to plot this point 8, -5, first of all, I notice this is going up by 2. So right away, 2, 4, 6, 8. I need to go over 8, 2, 4, 6, 8, and then down 5. So 2, 2, 4, 5. So this is point A. So remember, this is in the X direction and this is in the Y direction. The point 2, 0, so that means we go 2 over. Let's change the color. 2 over and 0 up, so that would be point B. Point C, let's do that one in blue, and that's 5 over, so 2, 4, 5, and then down 1. So there's point C. And then finally, point D, 1, 3. So we go over 1 and then up 3. So 2, 3. So right there is point D. So I'm just hopefully reminding you to move over left and right with the first number and up or down on the second number. All right. Hey, fractions, you know what? We'll do these, and if you catch it today, great. If you catch it tomorrow, even better. If you catch it in 3 weeks, in 3 months, it's better than not catching it at all. Hey, if you want to add fractions, you have to have the same denominator. So in this case, the lowest common multiple, the first number that both those numbers go into is 18. So I'm going to multiply the first fraction by a very fancy 1. And I'm going to multiply the second fraction by a very fancy 1. So this is equal to 1, and this is equal to 1. Now, when you multiply something by 1, it doesn't change it. It might change the way it looks, but it doesn't change its value. So if we multiply this first fraction, 2 times 2 is 4, 2 times 9 is 18, 3 times 9 is 27, and 2 times 9 is 18. So that is how we get the same denominator. And now that they have the same denominator, we can add the 4 and the 27. So we have 4 eighteenths and 27 eighteenths. So total we have 31 eighteenths. If you're like, whoa, I haven't been in math for 2 months, 2 years, I just think that if we do this at the beginning, you'll get better at it. Hey, improper fraction right here, you take 2 times 4 plus 1, so 8, so that is 9/4. So that turns into 4 minus 9/4. Remember, the 4 is the same thing over 1. The lowest common multiple of the bottom numbers is 4. 4 stays the same, and we need to change that into a 1. So I'm going to multiply by a very fancy 1. Notice that I'm trying to make that bottom a 4, so I get 16/4 minus 9/4, and that is 7/4. I know. It's like seriously day one. Yeah. Well, I don't want to I don't want to pretend that everybody can't do fractions. I just want to like hit it head on. So I appreciate your teachers before you if this was easy. If this is still, hey, as we do this, you'll get better and I'll get faster. So here we go. Hey, algebra. A lot of people come into this class having barely gotten by algebra, so we'll do a lot of algebra review. I'll just, I don't know, I'll do this one. This is part of your homework, so I'm doing one for you. So the key is to get all the variables on one side, all the numbers on the other. So I'm going to add 6x to both sides. The reason I add is because I have a negative here and I want to do the opposite, so those cancel. So now I don't have an x on that side. That's great. And the negative 13 stays. Minus 1x plus 6x is positive 5x minus 23. So this could be a problem right there. Minus 1 plus 6. It's like, dang. You can see that on a number line. This is 0. There's minus 1. And then from there you add 6. So 1, 2, 3, 4, 5, 6. So that's 1, 2, 3, 4, 5. So that's one way to look at it visually. Now we're going to add 23 to both sides because we're subtracting 23. We want to do the opposite. So those cancel. And now I get 5x. Negative 13 plus 23 is positive 10. 5 times x, the way we want to undo a multiplication is division, so we'll divide both sides by 5, and 10 divided by 5 is 2, and we have our solution. Okay, yep, we're going to get better at algebra one day at a time. All right, so I would assume that you can measure something. So if I were walking along the woods and I saw and I had this, so the top is centimeters and the bottom are inches. So if I come up here like this and I'm going to see this as 1 centimeter, 2 centimeters, 3, and then a centimeter broken down into 10 millimeters. So we can just count each one of those separately. 1, 2, 3, 4, 5. So I would say this is 3.5 centimeters. Interesting, sometimes when you're working in the house, sometimes you can't start at the 0, and let's say you start at the 2. Can you still measure it if you start at the 2? So here you have 2, and if you go over here, you have 5.5. So do you see that all you need to do is take the farther number and subtract the number here? So 5.5 minus 2 is indeed equal to 3.5. The exact same thing as we measured. Now, of course, if you want to start at 0, whatever you get to is the measurement. Sometimes you just can't start at 0 and you have to start at a number. You get to another number. All you have to do is subtract those. Pretty cool. All right, the ruler postulate just says that. Basically, wherever I am on the ruler x1 and I move all the way to x2, the distance between those is just subtract those two. Okay. The absolute value signs here just means, hey, distance, it's a positive number. Make sure this is a positive thing when you get done. When we use a ruler to measure with inches, it really isn't. This imperial system is awesome and it's worked well for us for a long time, but there is some benefits to the decimal system. We don't have a lot of time to do this, and this isn't the purpose of this class, but sometimes it's good to just talk about. If I were to measure this, I see that this is 1 inch right here, and to the nearest 1/8 means, all right, what do these break down? Well, if you see how this is the biggest one between 1 and 2, well, that's 1/2. If we cut that in half, we get 1/4. And if we cut those two in half, we get 1/8. So these right here are all the 1/8. So we go to 1 inch, so 1/8, 2/8, 3/8, 4/8, 5/8. So we would say this is 1 and 5/8. So maybe you're like, whoa, man, we'll keep working on that, especially when we get together. I'll have you guys have some tape measures, and it's a skill. It's like, no, I want to learn about cones and pyramids. We will, but I want you to be able to measure something. All right. Hey, some customary units of lengths. Why this is important, because in math, we're going to work with units the whole time. And I found that some people can get very far in life without knowing a few basics. And that is, for every foot, there are 12 inches. For every yard, there are 3 feet. And if I say a mile, I'm saying that there is 5,280 feet. So if you go to the Broncos Stadium, it used to be just called Mile High Stadium. That means the elevation above the ocean is 5,280 feet. And that's why they call it Mile High Stadium. All right. All right. So if you want to use this idea in converting, so if I wanted to find the area of this rectangle, I hope that you walked in here knowing that the area of a rectangle is length times width. So if I did this, this would be 2 inches times 6 inches, and that would be 12. You don't say inches because it's inches times inches. You'd say square inches. And what that means, a lot of people don't understand area as well as they should. What that means is I can break this up into 12 square inches. So each one of those squares is 1 inch by 1 inch. And that's important because maybe we want to know the area of a living room so we can order the right amount of carpet in square feet or square yards. All right. I don't think I'm going to convert this right now because I'm already at 14 minutes. I'd like to keep this down. All right, we talked about this today in class. This notation is so important. This is a segment. It is not a line. And when we talk about lengths, we don't put anything above the AB. Okay, we're talking about the line segment AB, but when there's nothing above it, we're talking about the distance from A to B. And distance is a number, a numerical value, and numerical values can be equal. So 5 can be equal to 5, 7 can be equal to 7. But when we talk about things that are shapes, and especially in geometry, we're going to do that again a lot. That little line above it says AB, the line segment. So it's actually that physical line segment, okay? And so we don't want to say that two physical objects are equal to each other. There's characteristics that are equal, like the actual length in inches. However, when we talk about two shapes being the same, we say that they're congruent. And this is a huge, important idea. So please, I'll go up here today. Please understand that if you have two segments and we say that their lengths are equal, that's how we do it. If we say the two segments are congruent, that's how we do it. Okay, and that symbol right there, go ahead and practice it real quick. It's just an equal sign with a squiggly. So that's when we're talking about two shapes. All right, so you're going to be these are questions off your homework. And I just all over the place here. I think this might work. So you're going to be asked, are the distances from JK and LM congruent? Well, this is really quite easy, and this is why I did the warm-up. All you need to do is graph those points. So I graphed J and K, and I graphed L and M. And the points that you're going to get are going to be right on top of each other vertically or horizontally. So you can just count the squares between them. And it looks like there are 5 between here and 5 between here. So I would say that JK is the distance from J to K is equal to the distance from L to M. Or I would say the line segment is congruent to the line segment LM. So those are two different ways to say that. All right, we're going to skip that next example. All right, the segment addition postulate. Is this thing for real? All right, so we have a line. Great. And in that line, we have these 3 points. Awesome. And you can kind of see that you can make 3 segments. You can go from A to C, A to B, and B to C. So there's really 3 segments. All right. All we're saying is the 2 little ones add up to the big one. The 2 little ones add up to the big one. So if I go from here to here, take a rest, and then I go from there to there, I'm saying that that's the whole length. I know. Let's see an example. Yes, these are off your homework right now. They want you to find the length from D to F. Okay, I know there's some eye rolling. I know you got this. 23 plus. So we would write this if we want to make a ton of money. We would be, we'll use the segment addition postulate. So we would write this as DF equals DE plus EF. And maybe, just maybe, we want to actually write this segment addition postulate. It's kind of like being a lawyer in a high profile case and you're saying something and then you tell why that what you said holds up in a court of law. Okay. Well, that's been established in this case and you reference the case. This is kind of what we're referencing. So everybody's, oh, yep. Most people say, no kidding. You take the little one plus the little one, you get the big one. Yeah. So DF would be equal to 23 plus 35, and hold your breath, that's 58. And you're done. You type in 58, the bells go off, everybody's happy, life is good. Uh-oh, man, what if they mess with you a little bit? GH, what if it's, come on. If I gave you this at the very beginning of class and said, this information, do you have enough to get GH? I would say 99% of the people would have a pretty good shot at it. Okay, so the segment addition postulate says FH, the whole thing, is equal to the 2 little things. So what do we know? We know FH, so we plug a 36 in there. We know FG, and we don't know GH. Well, that's why we take algebra, because now we can use algebraic manipulation and get GH by itself. Whoa, 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 we don't want to make that look bad. So we're going to subtract 21 from both sides, and we get GH alone on that side is equal to 15. Now maybe just by looking at it, you got 15. That's okay. Use your common sense. I love it. You can go fast here. That's fine. But please understand there is a method to this madness. We do little easy things so we can do bigger things later. We learn how to boil water in cooking class. It's like, and then you'll be amazed at the one person that just spills the water. Oh man. But you know what? They get over it and then they become the chef eventually. So let's have patience with everybody. All right. Hey, so you get these in context. This is the exact same problem as what we just did. We're given the whole length, 738. We're given a little length, 377, and we're asked to find Tulsa to St. Louis. I did a little picture here because you don't know anything about me. I used to be an engineer in the oil field, and this is exactly what I used to do. Those are filled with cement. We are cementing a big old oil well there, probably 8 or 9 hours of pumping cement down into the hole, and we'll talk about all that later because there's some good stuff in geometry that helps us. And you too could be making $82,000 a year starting salary right now for the stuff that you're going to actually learn in this class, finding volumes and so forth. So pretty cool. Tulsa to St. Louis. So if we say that LS is equal to LT plus TS. So I'm saying this whole thing is equal to this plus this. And then everything falls into place. 738 equals LT 377 plus TS. Subtract 377. That goes away. TS, Tulsa to St. Louis, is going to be 6, carry the 1, 6, 361 miles. Awesome. Same problem, not going to do it. So this is your homework. Now, this is not your homework. We're going to do this, in class on Wednesday. If you're thinking what I'm thinking, you might be done pretty quick, and that's okay, because then you can do your little homework in 15 minutes, maybe an hour, and then you have another 20-minute video. You're done skis. You don't have to do anything else. But strive to be really good this year, okay? So strive to get the harder problems. Ask those questions, and we'll go from there. I think that you can understand all of these. These are problems off your homework. Look at this. This is kind of what we just did. All right, we're looking pretty good. Number 29, I asked you to do a few of these. So maybe we just do D real quick. I don't know if that's one of the problems that I asked you to do or not. So point S is between R and T. So maybe we just draw a segment and we put R and T and then put S anywhere you want. Okay. Use the information to write an equation in terms of X. Then solve the equation and find these lengths. So what do we know? We know that RS is 4x minus 9. So we don't know what x is. We don't care. That's all right. We know that ST is 19. And we know that RT is equal to 8x minus 14. Okay, there's some value of x that we can figure out if I plugged it in, all the numbers work out nice, okay? So what this is asking you to do is use the segment addition formula, and that is RT, the big, is equal to RS plus ST. So from here to here is equal to from here to here plus here to here. Common sense. Do we know what RT is? You bet. 8x minus 14. Do we know what RS is? You bet. 4x minus 9. And then do we know what ST is? You bet. 19. So then, welcome to Algebra 1 class. Now that's our, we use the information to write an equation in terms of x. So that's what this is right here. But then it says solve the equation and find some values. So let's go ahead and solve this. We'll put together a few things. I'll move this down. Oh, look at those problems we did earlier. So we get 8x minus 14 equals 4x plus 10. So I put those two together. I'm going to subtract 4x. Some days I'll write all the algebra to help some people. Some days I'm just going to say it and then do it. So 8x minus 4x is 4x minus 14 equal to 10. I'm going to add 14. So we get 4x. Those cancel, equals 24. I'm going to divide by 4 and I get x equal to 6. You think that you're done, but now you have to use that and figure out each length. So RS is equal to 4 times 6 minus 9, which is 24, minus 9, which is 15. ST is equal to 19, and RT is equal to 8 times 6 minus 14. That's 48 minus 14 is 34. And there you have it. And if you'll notice, the two little pieces add up to the big piece. That's a great check. Hey, thanks for playing with me under 30 minutes. That is always our goal. Good luck.